I am going to explain about binomial distribution. If you want to get my future videos, subscribe my channel. Coming to the binomial distribution is used to find the probabilities for the given experiment. For the given experiment, but it is having one condition to calculate the probabilities. So that is the conditions are it should be having only two outcomes. If we consider any experiment, it should be having only two outcomes and having equal chance to get the outcome, equal probability to get the outcome. Then only it can exist. The binomial distribution can exist, will get the approximate probabilities. That you want to say. So for example, if you toss a coin, coin is having two outcomes, only two outcomes, head as well as tail. In that case, it can eligible. If an experiment is having more than two outcomes, it will not exist binomial distribution. And it is also having 50-50 chance to get the outcomes. 50%, and here also tail is also having 50%, means 1/2. So for that, in that case, he has given that is the binomial distribution NCX into P power X into Q power N minus X. Here X is the required probability X, and N is the number of times the experiment repeated. For example, if 10 times, if you toss a coin, so then N value is 10. So it is number of times the experiment repeated. That is an N value. X is the required probability. Here and N is also NCX, means NCX can be also defined as N factorial by X factorial multiplied with N minus X factorial. That is the NCX value. So then we can find easily the given probabilities. Here you can say this NCX into P power X into Q power N minus X. As I said, both are having equal probabilities. So probability to get head, I am assuming here P. So it is N 50% or 0.5. Probability to get tail is, I am assuming Q. That is equal 0.5 or else 1/2. So that is about P and Q values in the binomial distribution. So this is a mathematical representation for the binomial, and as I said, the condition is it should be having only possible two outcomes, either it is false or true, or else failure or success, or else yes or no, having equal probabilities. And coming to the application, by using this we can estimate many games of chance, and it is also used to detect the radar signals, and we can classify the defective and non-defective items. We can find the defective elements in a factory. Even we can find in a factory how many, for example, if we consider a bolts company, so how many will be defective, we can find. In mobile communication, how many calls will be fail, how many calls will be success from transmitter to receiver. Like that, we so many applications are there. By using this, we can find easily by using binomial distribution. So these are the advantages. So but he has given that it should be having it should be having two outcomes only. Two outcomes only. So then only it can exist ncx into p power x into q power n minus x. This is the binomial distribution. You will go with one example. So coming to here, if you toss a coin 5 times, then what is the probability? Exactly 2 heads. So that is the first one. According to binomial distribution, if you toss a coin, probability to get head is p equal 0.5 or else 1 by 2. 0.5 or 1 by 2. Probability to get head, this is p of h or p. Probability to get tail is q is 0.5 or else 1 by 2. And how many number of times it tossed? 5 times. Therefore n equal to 5 times. He is asking exactly 2 heads. First one, exactly 2 heads using binomial distribution. He may ask the question like this: find the probability using binomial to get exactly 2 heads. So that is equal p of x equal to 2 head exactly is equal ncx into p power x q power n minus x. So that is equal, n value is 5 times it tossed. Out of that we need to get 2 times 1 by 2 whole power x. How many times? 2 times. Q means 1 by 2 whole power n minus, n is 5 times out of 2. So here 5 times means we can write it as like this: 5 into 4 by 2 into 1. 1 by 2 whole power 2 multiplied with 1 by 2 whole power 3. 1 by 2 whole power 3. So now we can write it as 5 into 4, 2 times here, 2 into 5, 10, and 1 by 2 power 2 plus 3, 5 times. So that is equal 10 by 2 power 5 times means 1, 2, 3, 4, 5. 4, 8, 8, 16, 32. 32. So this is the probability to get exactly 2 heads. Exactly 2 heads. This is the probability if you toss a coin 5 times. So coming to the second bit, if you toss a coin 5 times, so n equal to 5 times, then what is the probability to get? He is asking at least 4 heads. At least 4 heads. So means at least 4 head means p greater than or equal to 4. Either 4 or greater than 4. That is the meaning. At least 4. At least 4 means either 4 or greater than 4. So that we need to find. We know that already. Probability to get head is 1 by 2. Probability to get tail is 1 by 2. Equal chance should be there. So therefore here probability to get x greater than or equal to 4 is equal ncx p power x q power n minus x. So n means 5 times out of that. So here he is asking that is greater than or equal to 4 means p of x equal to 4. This is equal plus greater than or equal to 4 means x equal to 5 because 5 times it tossed. So that's the reason x equal to 4 and x equal to 5. If it is only 5 times tossed, if it is 10 times tossed, so then x equal to 6 plus x equal to 7 plus until x equal to 10. So that's the reason here we need to find x equal to 4 means 5c4 1 by 2 whole power 5 x means 4 plus into 1 by 2 n minus x 5 minus 4 1 5 minus 4 1 plus 1 p of x equal to 5 5c 5 1 1 by 2 x value is 5 1 by 2 5 minus 5 0 because n minus x 5 minus 5 0 anything power 0 0. So like this we can find the probabilities 5 into 4 by 4 into, so here 5 into 4 into 3 into 2 divided by 4 3 2 1 multiplied with 1 by 2 whole power 4 plus 1 5 5c 5 1 1 by 2 whole power 5. So here this value is cancelled. So therefore 5 into 1 by 2 whole power 5 plus 1 by 2 whole power 5. So we can write it as 5 by 32 plus 1 by 32 equals 6 by 32. So this is the probability to get p of x greater than or equal to 4. So that is about binomial distribution. If you have any doubts and suggestions, send to me. Thank you.